Okay, today is January 23rd. It is almost a month past Christmas, which seems like so long ago. This is our Chapter 5 practice review, or chapter review, I guess they call it. First question is 6 questions that have matching sides to this. So the first one says, which one has 3W as a like term? So we look down at all of these choices here, and we decide which one is a like term to 3W. Now we know that like terms means it shares the same variable and the same exponent. So since the variable is W, the like term has to be W only as well, which means those are like terms. What are different about this term and this term? What's the only thing different between them? The coefficients, and the coefficients can be different when we combine like terms. That's actually the part that we combine. Question 2 says, which one has 3 terms, or another way to say that is which one of these is a trinomial? We know that terms are connected by addition, subtraction. So this is 2 terms, 2 terms, 2 terms, 1 term, 3 terms, 2 terms, 2 terms. So your answer for this one would be E. E is the only trinomial. Monomial is your 1 term. That is also D. Opposite polynomial to this. So we know the opposite of this binomial would be the opposite of each term. So if I was just writing it down, the opposite of 3x is negative 3x. The opposite of negative 1 is positive 1. And we talked about the fact that if we combine those two, if we added them together, we would always get what number? 0. So any polynomial and its opposite will always yield 0. So our answer for this one is A. A polynomial of degree 2. So remember, a term's degree, if I said this is a term, because it is a term, it's the product of x multiplied by y. So it's 2 variables. Multiplication only makes it a term. The exponents here are 1 and 1. We don't write it, but we know they're there. xy would have a degree of 2. But if it was xy plus z, this has a degree of 1, this has a degree of 1, this has a degree of 1. The degree of this binomial is not 3, it is 2. Because remember, when it's polynomials, it's just whatever term has the highest degree as the defined part of the polynomial. So polynomials with degree 2, degree 1, degree 1, degree 2, it is C. Right? Because the exponent 2 is on the x, that makes that term a degree 2, and it makes the whole binomial. Because this constant has a degree of 0. And finally, contains the constant term 3. This constant term is negative 1, positive 2 does not have a constant, positive 1, positive 3 is the constant, and therefore B is your answer. Remember, constant terms are those terms that do not have variables, variableless terms. Question 7, for each expression, identify the number of terms and whether the expression is either a monomial, binomial, trinomial, or polynomial. It is a little bit of a misnomer because anything more than 1 term, which is a monomial, is technically a binomial or is a polynomial, but those are 2 terms and 3 terms respectively. 1, 2, 3, 4, polynomial, 4 terms. 1, 2 terms, binomial, 2 terms. 1 term, monomial, 1 term. And then 1, 2, 3, 3 terms is a trinomial, and 3 terms, just it. That's all I need to say. Okay. Any questions with that? That's pretty easy, that one. That's not a hard one. Question 8, what's the degree of each polynomial? Explain how you found your answer. Well, look at that. It starts us off, says, what's the degree of a polynomial, but it gives us a monomial to start. How difficult to do. This monomial, this term, only has 1 variable with an exponent of 2, so the degree will be 2. This term in the trinomial has a degree of 2. This term has a degree of 1, and this term has a degree of 0. So the degree of the polynomial, or trinomial, is 2. Degree of 0, degree of 1, this binomial has a degree of 1. The invisible 1 exponent is all we needed to see. Question 9, provide an example of each of the following, a binomial. Obviously, the easiest one would be just x plus 1. That's one of the most common binomials, but you could have infinite number. A polynomial with 3 terms, the most common would probably be this one. A polynomial with a degree of 2, that's one. The more common one would, of course, be probably people who did a degree of 1 might have probably did that one. Degree of 2, sorry. And finally, a monomial that is also a constant term. You can take any number. Right? All of those would be numbers that are monomials that are just constant terms because they have no variable. So with no variable, it's a monomial constant term. Question 10, model each expression. So when we do the modeling, remember, that's our 1, that's our negative 1, that's our x, that's our negative x, that's our x squared, that's our negative x squared. Those are our symbols. So for A, 1 minus v, we're going to use the negative v or the negative x to represent our variable, and that is 1 minus v. B would be 3x squared, which is real simple. Hence the coefficient 3 can mean either taking this value and multiplying it by 3 or just expressing how many of them there are. Negative 2x's, open, and a positive 1 is just your integer chip shaded in. Just the two of them? Weird. Question 11 says, what's the expression modeled here? This is an x squared, so we're going to write that down. Notice we didn't write the 1 coefficient for the 19th time. Don't write 1 coefficients or 1 exponents. This is negative 3x, so that negative symbol is going to actually become our subtraction sign to combine those two terms. And the plus 2 or the positive 2, the positive symbol will become the plus sign to connect that trinomial together. In our second one, they're x squareds, but they're not shaded in, so it's negative 2 of them, negative 2x squared. That is just plus x, so that binomial is what's pictured there. And finally, the last one, we have negative 3x and plus 2, a binomial, degree 1, constant term of 2. Question number 12, you were selling used video games for $10 and used books for $4. The expression 10x plus 4y provides a general statement of the value of your sales before tax. What do the variables x and y represent? Well, x represents the cost of a video game. Sorry, the number of video games. The number of video games, not the cost, because we know it's $10. Yes, and y will equal the blank number of books. So once we know that, it makes sense because $10 per and $4 per means if I take the cost of $10 and multiply it by the number of video games I sell, that will be the money I generate from that. Question B says, how much money do you receive if you sell 6 video games and 11 books? On the test, if this question was asked, which it seems reasonable a variation will be asked, you always start with your expression. Then you substitute 6 video games will become 6 for the x, 11 books will become 11 for the y. You substitute it, and then once you have no variables left, you just have a bedmass expression. 60 plus 44, 104, and therefore you would make $104 if you sold 6 video games and 11 books. Did I have that backwards? No, that's right. Okay, good. And finally, C, what would happen if the DVDs were at $7.25 and CDs were $5? So again, I'd probably use D equals DVDs, or number of DVDs. And I'd say C equals number of CDs, like that. And then my expression would be 7.25 coefficient multiplied by D. That would be the amount of money I would generate from selling DVDs, plus $5 per CD would be 5 multiplied by the variable C, which represents how many CDs. That would be the new expression. You could have also used X and Y if you wanted to, as long as you redefined them like this. Any questions so far? We're good? Question 13, Tom claims that 4 and 4x are like terms since they both contain 4. Do you agree? Nope. Why not? 4 is the coefficient. They can be different. X is the term, and therefore since only one of them contains the term or variable x, you can't combine them. Question 14, for each expression, identify the coefficient. Okay, so I'm just going to use yellow for the coefficients. 8 is the coefficient. What's that coefficient right there? No, it's not. It is -1. And then the last one, does this have a coefficient? What do you think it is, Carter? It is not. 3, do you know if this is a coefficient? Does this have a coefficient? Bryn, do you know? What's the coefficient for this one? Doesn't have one. Why not, Caden? Correct. A coefficient is a multiplier of a variable. And since there's no variable, there's no coefficient. The exponent, we'll do in green. Exponent of 1, exponent of 2. Exponent of 2, no exponent because it's not a variable. And then finally, what are the variables in blue? X and Y are your variables. C is your variable. There is no variable. It's just a constant. Question 15, identify the like terms in each group. So, so I look at 7R's, start there. Are there any other R's? No, there are not. So there is no like terms for that. I'll just shuffle it over. I'll look at the next one. S's. Are there any other S's? Yes, there is. So this would, oh, that's not the color I wanted. This is a like term with 3s. So 3s and negative 8s are the same, just different coefficients. We then look at s squared. Are there any s squares? No. Are there any other constant terms? No. Are there any other RS's? No. So we're down here. Are there any other x squareds? Yes, there are. So these two are like terms. Coefficient of negative 2, coefficient of 1. They are like terms. Go to our next color. Are there any other xy's? Yes, there are. In fact, they're the exact same number. And the other two, which are a constant and a y variable, they do not have any other ones, so they're not matching. So those would be our matched terms for this. Question 16 says, explain how you could tell like terms by looking at them. Give 4 different sets of examples. I think we said we could skip that. It's too much work. Question 17, the following diagrams represent terms in an expression. This looks like a trinomial. And if I look at that, it's a binomial. Draw a new diagram with the like terms together. So, are there any other of these? No, there are not. So it stays by itself. I cross it out. This x and this negative x make a what? Specifically, an algebraic zero pair. So they're going to be gone. I'm left with these 3 left. So I'm going to draw 1, 2, and 3. And then these 5, this 2 and this 3, are going to combine to make 5 of them. I'm just going to make circles because I'm too lazy to do squares. And that would be our picture that says. And what does that say? It says the whole expression would have been negative x squared plus x plus 2 plus negative 4x plus 3 equals negative x squared minus 3x plus 5. Was that Blaze? Or someone else? Question 18. Use materials or diagrams. We're going to just use algebra tiles to model this and combine like terms. So for A, 3, negative 2x, positive 1, positive 5x. That's the picture. Those are the 4 terms. When I gather like terms, I'm not going to gather my constants first, even though they're the first thing I see. Well, I'm smarter than that. Create your 0 pairs here. You're left with 3x. Your constant terms, no 0 pairs, it just makes 4. Your solution through drawing is 3x plus 4. For B, 2x squareds, a negative x, a positive 4, a negative x squared, a positive 5x. And a negative 1. There's our picture. When I can make my 0 pairs, I'm going to take one of these and one of these, cancel it out, leaving me with just an x squared left over. One of these and one of these makes 4 x's left over. And one of these and one of these makes a plus 3 for my constant. So the solution to B would be x squared plus 4x plus 3. Question 19, combine like terms. Now we don't have to draw it, piece of cake. Look for your highest degree terms first, since there's only 1s and 0s. I'll collect my A's first. The A stays, the coefficients get combined to make 13A. 3 and 1 plus 4. Look at the next one. I have 4 terms, degrees of 2 and degrees of 1. Combine your degrees of 2 first, making 6b squared. Combine your constants of the next one, negative 5 and positive 8 makes positive 3. So your answer is 6b squared plus 3b. And finally, you have 1, 2, 3, 4, 5, 6 terms Degrees of 1s and degrees of 0s. Fortunately, all the degrees of 1s are the same. So you have negative C, positive 6C. I'm going to do my positives first to give me 8C. And a negative 1 makes 7C. Done. All my C's have been taken care of. 1, 5, positive 2. When you combine 1 plus 4 plus negative 3, it makes positive 2. Question 20 says, draw a shape with the perimeter represented. Since we have 4 sides, but none of them are equal, we're going to make a polygon, a 4-sided figure, that is not in any way the same shape. So I have 4 completely different side lengths. I'm going to guess the longest is 4x, and I'll make this the longest. Maybe this is 3x minus 1. This would be x plus 3, and probably x minus 2. I don't know. Did you make the same one? Great minds think alike. Where each quantity parentheses, okay. Find a simpler version for the perimeter by combining like terms. So the perimeter would be the sum of all sides, or an x plus a 4x plus a 3x, which is 9x. And then a negative 2 and a negative 1 make negative 3, and a negative 3 and a positive 3 make 0. And since 4x doesn't have a constant, my constant terms are going to cancel each other out, leaving me with a simplified perimeter of just 9 multiplied by x. That's a good question for your test. Asterisk, it will be on there. Question 20, Kara and Jasmine go a Splashamania water park. The entrance is $20. Kara rents a locker for $1.50 and Jasmine rents an inner tube. Oh, I remember this question. We've done it already, haven't we? What expression represents the cost for Kara? So Kara, right. Kara is just going to spend $1.50 per hour. So if H equals the number of hours, right, but she's still going to do per hour. So it's $1.50 multiplied by the number of hours, oh, so H, multiplied by the number of hours, plus she has to pay $20 to get in. Now, for those of you who are astute, some of you probably realized that that's still $1.50 per hour, because $1.5 is still $1.50. If you put the 0, no problem. If you didn't put the 0, it's better. That's okay. For Jasmine, same criteria, H equals number of hours. She's $3 per hour, which is 3 multiplied by the number of hours, plus 20. And then it finally says, what is the simplified expression for the total cost for both? So if we had Kara plus Jasmine, we're going to have 1.5 H plus 20. That's the cost for her. Plus Jasmine's will be 3H plus 20. When we gather like terms, we are going to be gathering coefficients, Zach, that have decimals. It's okay. What will my H term be? Z? So when you combine your coefficients, you keep your H, you combine your coefficients to get 4.5. If you have 4.50, that's still good. Plus 40, because that's going to be the cost of 2 of them getting in. And that is finally the last answer. Okay, Carter, since you seem exasperated, simplify each algebraic expression. When you combine your x terms, oh, by the way, what's the operation in here? Oh, is this 2 different things? Oh, it's 2 different ones. Okay. Carter, what do you get when you combine those 2 binomials? Excellent. And what do you get when you combine these 2? No, you don't. Do you see a subtraction symbol? So when you have this on your test, here's what I want you to do. Keep your first impression, change it, and physically write the opposite. Don't do this. Because if you do that, unless you want to, I'm not going to stop you from doing it. But I know from experience, people who do that make the most mistakes. Because they've changed the first one, don't change the second one, or they can't read their own handwriting. But by looking at it this way, you definitely know when you gather your x's, you're going to have 3x. When you gather these 2, you're going to have -2. So your solution for the second one, when you combine these 2, is this. But remember, it's subtraction. How are the processes similar? How are they different? Well, of course, the way they're similar is eventually you're simply going to gather like terms. The only difference is when you subtract, you first have to write the inverse of the addition. Then you will gather your like terms. So it's always going to be gathering like terms. It's just easier when you, same thing. Is 2x squared minus 3x the opposite of 3x minus 2x squared? Show how you know. The answer is yes, they are opposite. And the reason why they're opposite is this one has the degree of terms in descending degree. This one does not. If I rewrote this one, this is my first term. This is my second term. I got to put the positive sign because it's a positive 3. And when I look at it, now it makes sense. These are opposite, and these are opposite. So therefore, yes, it is opposite terms. That's a great true-false question. You know how I love my true-false questions, right? That seems to be one that I would love to use. Be a wonderful test. For each of the following questions, what's the opposite? Piece of cake. 3, negative 7 plus a, negative x squared plus 2x minus 4. That is about the easiest question you'll get if you have that on your test. Yep, bet I am. Question 25. Show how to simplify the following addition. Use 2 different methods. So you could, in theory, use, instead of using algebra tiles, you could use different symbols for p. I'm going to make p that. And I'm going to make q that. And I'm going to make 9, negative 9, that. Now 2 will be this. Negative 5q will be a q with a circle around it. I'm making this up. I've never done this before. I'm making this up on the spot. And a negative p will be a p that's circled. That's a negative p. You could do that as well. So these are positive p's if they're not circled. Those are negative p's if they are circled. I now know that one of these p's and one of these p's is going to make a 0p, a no p. These 4 q's and these 4 q's will make no q's. I'll be left with just a q and 2 p's. So I'm going to put 2p plus 1 q. And then these 2 and these 2 will make 0, leaving me with negative 7. And that would be your solution. Now, some might say, Mr. Mack, do I put my p's first or my q's first because they're 2 terms that have the same degree? It does matter. How should you order them if they both have the same degree and they're both single terms? Close. No. Alphabetical order. You will do it in alphabetical order if they are both degrees of one single variables. That way they're all going to be the same answer. Question 25, combine like terms. Piece of cake, 3p. Oh, 26. Plus 2. Here, don't forget to write it out as the opposite first. Then ignore it. Don't bother looking at it anymore. You'll screw yourself up if you do. Gather your a squares to get 4a squared. Gather your a's to get negative 7a. And gather your constants to get negative 7. This is a subtraction pyramid. So it says a subtraction pyramid, meaning find the value in any given box by subtracting the 2 expressions in the boxes immediately below it. So this will be t minus 1 take away 2t plus 3, right? Which will be t minus 1. How many of you did addition pyramids, just out of curiosity? Didn't read the instructions properly? Okay. Plus negative 2t minus 3. When you gather like terms, this will be a negative t, and this will be a negative 4. When you do the next one, it'll be this. Take away this, which I'm going to immediately just add the inverse. It's going to be a positive t and a minus 5. I'm saving myself a half a step. Therefore, this will be 3t minus 2. And finally, the last one will be this, take away this, or this. Take away, which will become addition, because I know I'm going to switch it, to the opposite, which would be negative 3t plus 2. Now I just have to gather my like terms. My top step will be negative 4t minus 2. Okay, our last question says an end-of-year class party has a fixed cost of $140 to cover printing, decorations, and awards. So no matter how many show up for the party, you got to pay out $140 to pay for those things. In addition, it costs $12 to feed each person who attends. What is an expression for the total cost of a party? Okay. Most importantly, what does your variable represent? So what will x be? No. No. What will X represent? Number of people is correct. So we're going to put number of peeps that attend the party. So since it costs $12 to feed a person, it's going to be 12x. That's the cost of feeding however many people show up. If 100 people show up, it's 12 times 100, which was $1,200. Plus, no matter how many people show up, it's still going to cost us that $140 to print the decorations, awards, and whatever else we have to print. Then it says create a short scenario to generate addition and subtraction question with polynomials, simplified by combining. I said you didn't have to do that part, did you? Correct. That's it.